All right, so let's again see this question that I am solving, which is children's side. So I think I will dark theme. Let's switch off the dark theme and let's see this question again. I think the dark theme was much better than this. Okay, how did I go through that? I think switching on is better option. So see in this question, n children will be standing over here. We will be given an array of, suppose take this example. Okay, let's write 6, 20, and 1, 8, 10, 18, 19, and 17. All right, now as you can see over here, this is the array that is given to us, right? Now we are given that we have to find the maximize the happiness index if you can give maximum m candies to the children. Okay, so we are also given m. So let me walk you through the example. See, we will be given a value of m which is 20 in this case, right? And we will be given an array. So what we can do is that we can take one uh, take one element of the array, right? And we can change that height to any amount, and whatever change we make to this array, suppose I make this as 21, so then m will be 17, right? So if I make this 28, then this will be what? 10. So yeah, so whatever changes you are making in this array or adding this, that much will be subtracted from the same, right? In this way, it is said that we can only increase the height, we cannot decrease the height. So as we can increase the height, what we can do in this case is that as you will increase the height of any element of an array by any amount, that amount you have to subtract from a. I think this is the approach. This is not approach, this is a problem description. So you might be thinking that greedy से sort कर देंगे, हम एरो को sort कर देंगे, एरो को sort करने के बाद हम क्या करेंगे, सबसे सबसे छोटा एलिमेंट को लेंगे, उसको ऐड कर देंगे. पर we don't know the amount ना, कि how much amount, or the how much amount can the this smallest element can be increased. Okay, now one approach that is coming to my mind can be a priority queue approach, where I can put like the only the two elements. Okay, I will take 1 and 8, right? Now I can take 1 and then increase. I will first of all, what I will do is that I will make a priority queue. Okay, priority queue will contain, suppose, okay, so what initially what was the value, which was 8, 10, and this was 18, and then this was 20. So priority queue initially values will be like 19, then 18, then 17, then 10, then 8, then 1. So when you will take 1, when you will take 1, right, as you will be taking 1, so I will be pushing this 1 value inside the array, then m value will be. Okay, means what I'm trying to say is that I will first pick 1 and 8, the top two elements of the parity queue. When I will be picking this 1 and 8 over the parity queue, I can like see that I can increase the smallest element by you can say by 8. Okay, if this value 1 is less than m, means 8 minus 1 is what? 7. So that is the difference. This difference, if this difference is less than m is the maximum allowed changes that we can have, then we can just make this as 9, right? And then I will push this again back. So as it was popped, now this will be 8, 9, and then 8. Again I will do this process. So you can see this, if we do in this manner, this is very much dependent on the value which is m. But you can see the constant here is that m is 10 to the power 9, I guess. So 10 to the power 9. If the m value would have been less than 10 to the power 8, then this approach would have worked very well, because we are just taking this value from the element and then pushing it. So this whole approach would be like big O of m log n. So m and the login for this login for the priority q2 function, right? N is the number of elements. So that is not an approach. That is not an optimal solution. So to solve this problem, what I have devised is that I will be using binary search, because binary search, if we implement binary search, then log of 10 to the power 9 will be around 9 something. So yeah, it's a good time complexity and it can be accepted. So I think the only approach that can come to my mind is binary search, right? So first of all, let's this will be a category of a binary search with a on the solution subset. Means the solution, what can be the what solutions can be accepted or what solutions are possible. We will traverse and check the condition for that solution and check if for this condition solution is possible. If the solution is possible for a given mid value, right, we can decrease or we can shorten the search space. So I will explain you it in a better way if I will write the code. So high value will be 1 in 9, right? Now while low is less than equal to high. Now, in this binary search question, we have given that we have to maximize this happiness index. So answer will be low, and what I will do is that I will be making a mid value. I should just not light this up, not this. Uh, yeah, charge is also draining. Let's connect this low plus high byte, if possible, of uh, I don't know, maybe N M A and then mid. Answer is equal to low, and low is equal to mid plus 1, else high is equal to mid minus 1. Get an answer. So we mid. Let's also try to do like this. Let's define this vector, and what I can do is that I can make a value mid. So then what I can do is that int answer is equal to 0, or we can say not answer. Let's make this as count is equal to 0. I will be reducing the search space between low and high, and I am doing binary search, so I will be implementing a mid value. Now what this mid value will be doing is that we are given the array 1 2 3 and then 4. Let's take the simple example 1 2 3 4. So the mid value will be, okay, this is m is very short, so let's make us see this. So let's see that I can make the mid value as 7, because 14 plus 0 by 2 is 7. Now what I can do is that okay, so 2 for the 7 to be accepted. So when I do 19 minus 7, it is 12, right? 12. So 12 change. So we have to, like, for 7 to be the largest value. Wait one second. Wait. So if 7 is the answer, if 7 is the answer. Okay. 7 is the answer, which means that yeah. So see, this 2 is less than 7. So 7 minus 2 is 5. 7 minus 4 is 3. 5 plus 3 is 8. 8 is less than 14. So yeah, it's possible. Means we can make the smallest height as 7 without any problem, and that values will be subtracted from 14, right? So that is the main thing that I will be doing over here. I think you got it, and I really don't need to explain or something like that. uh, yeah, so if the value of a of I is less than m, I can, like, so count plus is equal to a of m minus a of I. Return count is less than equal to m. Yeah, I think this much is sufficient. Let's test this. Wait. I think I have done one mistake over here. Okay. What has happened? Why is it? At least it should show me runtime. I have not used mid anywhere. That's a big problem. Okay. Not a of I, but if a of I is less than equal to mid. If a of I is less than equal to mid, then count plus is equal to mid minus a of I. What has happened is I don't know. The internet connection is also fine. What is happening? Yeah, I think the server issue is there. Okay, this is wrong answer. I don't know why it showed wrong answer. Oh, okay. Okay, so this is mid. Uh, okay, let's see why did it show me this big value over here. Count we're iterating. If a of I is less than equal to mid, we will make count as mid minus a of I. Yeah, I think this is it. Why is it not? Okay, this is a big problem over here. Hmm, why is it not working? Why is it throwing such a big input? I mean, big output over here. See, what is happening is that it is making this possible. Suppose let's take this 85,000 over the mid. Yeah, is less than equal to mid. Then I will be making count plus is equal to mid minus a of I. So yeah, it should not work. How is this happening even? N is this right? N is 4, yeah. M is also there. Due to this part or something like that. Ah, see, this int was making problem. Why did it show a wrong answer over here? So this was the overall approach. Okay, let me think. Why did this throw me a wrong answer? So is it that let's make this because the constraint was 1 in 9, so I think that might be a problem. Maybe I don't know. No, it's not the problem. I don't know why. Okay.